So I said before that the type of atom that makes up this penny is different from the type of atom that makes up this foil. And that was because the penny is made of the element copper and that the foil is made of the element aluminum. So what makes copper atoms different from aluminum atoms? The answer is that it all has to do with the number of protons in the atom. So on the left is a representation of an aluminum atom, and on the right is a copper atom. Remember that we were using a green circle to represent a proton, a blue circle for a neutron, and a smaller red circle for an electron. The thing that makes something an aluminum atom is the number of protons. If you count the number of protons in the aluminum atom, you'd find that it adds up to a total of 13. And this is what makes it an aluminum atom. Aluminum atoms can have different number of neutrons or different number of electrons, but every single aluminum atom will have exactly 13 protons. If you counted the number of protons in the nucleus of the copper atom, you'd find that it adds up to a total of 29. It's this total of the number of protons in the nucleus that is the difference between an aluminum atom versus a copper atom. In fact, the identity of any atom is given by the total number of protons it contains, regardless of the number of neutrons or electrons. The name for the number of protons an atom contains is called its atomic number. Since an aluminum atom always contains 13 protons, aluminum's atomic number is 13. Since a copper atom will always contain 29 protons, its atomic number is 29. If these numbers sound familiar, it's because they correspond to the numbers that were on the periodic table that we looked at earlier. Notice that aluminum, whose chemical symbol is Al, is in block number 13. Notice that copper, whose symbol is Cu, is in block 29. The elements are arranged on the periodic table according to their atomic number. So if you ever need to know the number of protons that are in the atom of an element, just look at the number at the top of its block in the periodic table. For example, hydrogen is an element whose symbol is H. Its atomic number is 1 because that's the number in the block. What this means is that every hydrogen atom will contain exactly 1 proton. Fluorine is the element whose symbol is F. It has 9 protons. You can tell this because the number at the top of its block in the periodic table is 9. So far we've gone over what is meant by atomic number. That's the number of protons that are in the nucleus of an atom. There's a couple more definitions that we need to get used to that describe an atom. Those are mass number and charge. To understand what both of these are, we're going to need to recall some things about protons, neutrons, and electrons. What we need to go over is the mass and the charge of all of these particles. A proton, which we're going to be representing with this green circle, has got a mass of 1. The unit for this is AMU, which is atomic mass unit, but typically when you talk about mass, you just give the number. You don't need to give the unit with it. A neutron, which we're going to be representing with this blue circle, has also got a mass of 1. An electron, which we're representing with the smaller red circle, we will consider its mass to be 0. Okay? Remember, this is the case where it's not exactly true to say that its mass is 0. An electron does have a little bit of mass, but it's so small compared to the neutrons and the protons that as far as the mass of the atom is concerned, you can consider its mass to be 0. The charge of the proton is positive 1, the charge of the neutron is 0, and the charge of the electron is negative 1. So the first definition we're going to be going over is the mass number. The mass number for an atom is defined as the sum of the protons and the neutrons in an atom. So we've talked a little bit about mass before, and mass is a little bit like weight, all right? Although they're not exactly the same. Mass is essentially how much stuff something is made of. So why is it that you can essentially determine the mass of an atom by simply counting up the protons and the neutrons? Why is it that this definition doesn't have anything at all to do with the electrons? So to explain this, I'm going to start with the representation of a very simple atom. Okay? We've got 1 proton, 1 neutron, and 1 electron right here. Okay? So let's go back up to this information right here. If we wanted to know what the mass of this entire thing was, the first thing that you've got to start with is say which of these things has mass to begin with. All right? Well, what this says is that a proton has the mass of 1. Okay? So this thing right here, we could say that it's got a mass of 1. A neutron also has a mass of 1. Okay? An electron is considered to have a mass of 0. Okay? So just like you could consider your body weight to be the sum of the weight of all your individual body parts, the mass of an atom is just the sum of the mass of all the particles that make it up. So the mass of this entire atom would just be the masses of all of these different particles added up. Okay? 1 plus 1 plus 0 equals 2. That's what the mass of this particular atom would be. One more example. In this particular representation of an atom, we've got 1, 2, 3 protons and 1, 2, 3, 4 neutrons in the nucleus. We've got 1, 2 electrons. Okay, so what would the mass number of this atom be? Going back to the definition, the mass number is going to be the sum of the protons and the neutrons in an atom. So therefore, for this particular atom, you would say you've got 3 protons plus 4 neutrons. So that gives you a mass number of 7. Okay? Notice again, the number of electrons that an atom has does not affect what the mass number is at all. You only have to look at the number of protons and neutrons in order to determine the mass number.